board. Perfect. We will share the screen. All right. No, this is not the question I want to start at. Don't look at it. Don't look. All right, let's do this one. All right. Oh, I got to do my polls too. Let me get going on that. Okay, this only has 3 options. Do I have a 3 poll? I don't. So I'm gonna make a 4 poll, and hopefully you're fine with that. You don't get too upset that there's a D. I'll give you a big hint. The correct answer is not D. And this is a really nice question because again, I don't think you can lie your way out of this one, right? You kind of have to know exactly what you're doing. Okay, so we're approaching in on 2/3 of the class having answered. So I'm going to give you about 30 more seconds in order to answer this. And it occurs to me last time, I promised you I was going to tell you the person's name who I mispronounced like the entire year, or for like 3 years rather. Okay, so I'm going to put it in the chat. Okay, so that's her name. And for like 3 years, I mispronounced it. And if you, okay, yeah, so you're all mispronouncing it as well. No?
Was it Rado?
Yeah, exactly. Yeah. So it might just be like geographically obvious to some people, but yeah, this is Rida, right? So I was saying Rita for a long time, but no, it's Rida. And so eventually she was just like, no, it's not hard to pronounce. It's just I didn't know, right? Because I never heard her name said out loud, right? So when you only read it, like I think a lot of us would default to not that, right? I think it was in her at the end of the 3rd year that she corrected me on it. And then we sat there for a while, and right, it had so been ingrained in my mind that it took me a while to break it, but I did eventually. Yeah, Florida. Yeah, exactly like that. Exactly. So, and I mean, I'm certain I'm getting many of your names wrong as well, but hopefully I'm getting close enough, right? That's sort of the idea. Okay, let me stop the poll here. Let's share the result. Okay, so we're kind of split on A and B, and we definitely have at least 2 jokers who decided that D was the correct answer, or maybe that's you signaling to me that you didn't know the answer. That's totally okay as well, right? I'm not terribly upset. Yeah, I mean, it was going to be one or the other, right? It probably wasn't going to. Where does she come from? That's actually a really interesting question. I'm not certain where originally, but like they grew up in Ireland, so they had like an Arabic Irish accent. Anyway, it was very unique, right? Very unique. Yeah, yeah, but again, they like grew up in Ireland, right? So
it's a very Middle Eastern name. That's why.
right, yeah. So if you're Middle Eastern, maybe it was obvious to you, but you know, you can imagine it wasn't as obvious to me. Okay. So this question, I don't think it's going to be worth redoing because it's basically, there's only three possibilities. And again, almost certainly, you know, it probably would have been reasonable to guess that they're not going to be equal. So one's going to be bigger than the other. And the key to this, which question is this? This is question 6. Yeah, this is question 6. Okay, so the key here is to keep in mind that, remember, when we bring payments, it doesn't actually matter that it's an annuity. We actually could have just thought of it in terms of a single payment. So let me say that. So thinking of it as a single payment, because the same principle is going to apply if there are multiple payments or a single payment. So thinking of it as a single payment, right? So we're told that the present values are the same and the payments are the same. But if I bring it back, RA, like this, and then I bring them back into the present, right? It's this sort of question. We know that these two things are equal. And so I'm asking you which rate was bigger, right? Or actually, sorry, it was 1,000 and 2,000, right? We actually know that these numbers are different. These are equal, so which rate is bigger? Now, the key to keep in mind is that when you push money forward into the future, the bigger rate gets more money, right? That makes more sense, right? If I push money forward and I compound it 2%, that's not going to be as much money if I push forward at, say, 10%, right? The 10% is going to earn more money as I push it into the future. That means that the discount is going to be greater when I pull money into the past, okay? So the bigger rate will have a bigger discount when I compute its present value. Does that make sense? Because think about it, if I go forward and then bring it back, it has to be equal, right? So if I got a big jump when I moved it forward, then when I bring it back, I need a similarly big jump for it to come back to the same amount. So the higher the rate, the bigger the discount. So the higher the rate, the higher the discount. Okay, so these both have to be equal, but one of them has a much bigger payment that you're trying to bring back into the present, right? So which of these schemes, right? This one here is A, this one's B. Which of these annuities has to have a bigger discount for them to both end up being the same amount of money? Yeah, discount just means, right, when we bring money into the past or into the present, it becomes less valuable than where it was when it was realized. And so the discount is how much does that decrease by, right? And exactly, everyone, right? B is the bigger payment. So in order for them to be equal, I have to apply a bigger discount to account B. So for these to be equal, account B must have the bigger discount. And so must have the higher rate as well. And so must also have the higher rate. Okay, so that tells me that RB is bigger than RA. Actually, well, let me write it the same way that we wrote it in the thing. So RA has to be bigger than R or less than RB. That's the answer A. Okay, how does having a higher discount make them equal? Okay, so let's think about it like this. Let's say they both had the same discount. Like let's say when I brought them back a single compounding event that they discounted to 95% of their current value. If they were equal, then A would be worth $950, right? And B would be worth $1,900, right? So B would be bigger. Do you agree? So if I pull them back both and they both discount by 95%, then because B was a bigger payment at $2,000 to begin with, it would stay as being a bigger payment. So in order for me to bring down the B payment, right, so that it equals, say, $950, I need to discount it by a much bigger rate. I have to discount it to like 50% or something, right? A little bit over 50%. So it has a bigger discount, right? Okay, cool. Yeah, so it has a much bigger discount and therefore must have the higher rate as well. And so hopefully it helps to think about it like that. Think about it as like actually you're getting a deal on this payment. You're getting 10% off of the $1,000 from A. And so you must get, if that $2,000 is going to give you the same amount of money, you got a much bigger discount on B, right? If B is right, so Agam, this is the same sort of thing, right? We could just work it out. Let's say we knew what the discount was. All right, we had $1,000 discounted by 10%, and so let's say it became $900, right? So now I have $2,000. I need to discount by I don't know how much percent to get also $900 because we said their present value had to be the same, right? So what is the discount that I have to apply to the $2,000? Well, what does it end up being? It's like, what is it? I need to get it to 900. So it's like 55%, right? 55, whatever it is, right? It's somewhere around 55.
It is 55.
It is 55, great. And you can see, so the bigger, right, in order for me to get 2,000 down to 900, I had to give a much bigger discount than to bring 1,000 down to $900, right? Yeah, sure. Can we see the question again? Right there. Right, exactly, Christian, exactly. Because B was the bigger number at $2,000, it needed a bigger discount to end up being the same amount of money at the end of the day. And the bigger the discount, the bigger the rate, the bigger the discount, and vice versa, right? The bigger the discount, it must have come from a bigger rate as well. Okay, so does that clear up everything for anyone who still might be confused? Okay, maybe let me go back here, right? Yeah, and I think like thinking about it again in terms of discounts is really gonna help you visualize which of these two numbers is bigger. Can you do it with future as well? Yeah, and I mean, like this is actually when we do it with future value, that's exactly what effective annual rates are, right? Do you remember when we were doing these questions last week about which was bigger, the effective annual rate or the effective continuous rate? That was the exact same thing, where we were taking a principle and we were pushing it forward a year. And we're saying at the end of the year, these numbers have to be the same. But the continuous rate compounds so much faster that it actually has to be using a lower rate in order for the two numbers to be equal after 1 year, right? So if you go back and you take a look at those poll questions, it was exactly the same sort of reasoning, only moving forward in time. And this time we're taking that reasoning and we're applying it to the present value and bringing everything back into the present, okay? All right, any other questions about that one? Is that okay? Excuse me. All right. I'm going to assume it's all right. All right, sweet. Do I want to do this? Sure, why not? Let's give this a shot. Where's my polls? There it is. Relaunch. Okay, and so while people are answering, there's something that I think is worth discussing here. So do you all know you can actually buy annuities? Like this isn't just a hypothetical thing, you can actually purchase them, right? Have you heard of this? This is something most people don't worry about until they get much older, but it is a thing. Has anyone heard of this? No? So normally it's a retirement vehicle. Okay, so right. So here's kind of how it works. Usually you retire, you're like 70 years old or something, and you might go in and you'll buy an annuity. And the way that you buy an annuity is, I mean, your age does come into it. Like the bank is, because the bank is trying to figure out whether you're going to die soon or not. But let's pretend that that's not a thing for the moment. What you can do is you can go into a bank and you can be like, I want to buy an annuity. I want to be able to guarantee that I get back, that I earn $2,000 a month every single month, right? And you might have, like, you might be sitting on a big thing of cash, but you don't want to manage it yourself. So you say to the bank, I'm going to give you, $300,000. And in return, I want you to pay me $2,000 a month for the next 10 years or something along those lines, right? In practice, you would indicate how much money you wanted a month, and they would tell you how much money to give them. So that's what purchasing an annuity is. And most people do it when they're quite old. And okay, so does that make sense? Like that's what an annuity actually is. And if you have like a defined benefit pension plan, it's something very similar where you're guaranteed, $3,000 a month every month of your life until you die, once you retire, sort of thing. So that's what annuities are. Now, if you all want to understand how amortization works, right? So amortization is you take a loan. Let's say you take a loan for a mortgage on a house. And let's pretend that we live in, 10 years ago when houses weren't insane. So let's say you buy a house and your mortgage is $300,000. What is happening is the bank is going to give you $300,000. And in return, you give the bank $2,000 a month. That's exactly an annuity, but in reverse, right? So remember, in the first scenario, I would give the bank $300,000 and they would give me $2,000 a month for the next 10 years. A loan is the opposite. The loan is the bank gives me $300,000 and I give them $2,000 a month back. So when you think about what a loan is, it's just you as an individual, or the bank is purchasing an annuity from you, right? That's the idea that you're supposed to have in mind conceptually. That's how a loan works. And the value of a loan or the value of an annuity is always the present value of the annuity, right? So that means the value of the loan is always the present value of the loan. Does that make sense? Right? It's what I'm willing to pay today to cover all of those payments in the future. That's the present value of the loan and of the annuity. Okay, we're at 2/3. I'm going to give you about 30 seconds. I think some people might be a little bit, based off of like how long it took us to get to 66%, I think some people are going to be really upset when they find out what the answer is. I can't believe we didn't make 28 an answer, but
I was gonna say, I don't know why. I was looking at it a few times, and I generally do not understand why 36 is an answer there. I was just thinking that in my head the whole time.
Yeah. Okay. So we're going to end the poll. Let me share the results. All right. I'm glad that the confusion is on B and C, right? So some people were thinking positive 12, some people were thinking negative 12. Remember, present value of an annuity, present value, what's the exponent? Is it positive or negative? Anytime you do, exactly, right? Whenever you do present value, the exponent is negative here. So in this case, you can kind of use that to rule out A and B because we're trying to compute a present value. Now, the question is how much is still on the loan when there are 3 payments left, i.e., what are we asking? We're asking for the present value of the loan when there are 3 years left on the loan. Does that make sense? Does everyone agree? And Josefa, exactly, with a negative sign, of course, right? There are 3 years left. Payments are being made quarterly. So how many compounding periods are left? There's 12 of them. And then we remember it's present value. So the answer is going to be negative. So our correct answer there is C. Right. And that's what I'm saying. Like, I think that on the basis of how many people, right. Yeah, exactly. And so this is, and I got a direct message saying, you know, like, I thought we were trying to find the future value. Why is it present? The value of a loan at any time is its present value. Okay. Right. And this is what I was trying to tell you with my story. The value of a loan at any period in time is the present value of the loan, right? So at the beginning of the loan, when you first get the big sum of money, maybe $300,000, that's the value of the loan, right? You go to the bank, you say, I want $300,000. They give you $300,000. That's the value of the loan. 5 years later, the present value of the loan is the present value of all the remaining payments, right? So you'd move forward 5 years in time and compute the present value of the remaining payments, and that's the value still remaining on the loan. That's right. So that's how you actually compute that. The loan is always present value, always. Now, I say that, but sometimes you might be interested in figuring out how much interest you paid on a loan. In that case, you actually need to, that's not a present value calculation. That's just how much were your monthly payments times the total number of compounding events. Is there any time you would want to future value it? I can't think of it. But one thing I'd recommend against is, again, you don't want to meta this too bad. You don't want to say, oh, if I see an amortization problem or a loan problem, it's present value. You don't want to think about that, because in theory, I could probably come up with a loan question that wasn't present value, right? So instead, you want to make sure that you understand what that present value is calculating and what you're being asked to compute, and that you're making that sort of association instead, right? Like you want to be careful. Most of the computations are present value, but it's very reasonable that I could come up with one that isn't. So don't fall into that trap and just make that association, right? The value of the loan 4 years later is the present value of the loan. And direct messenger, yes, that's why it's a negative power. And here, let me, well, I don't know, Anaga, I kind of have to think about it a little bit, but like, for those of you asking, like, I don't think there's much to say in this question because the answer is 3 times 4. But in terms of the present value, I can answer that. So let's say that these are your payments on the loan. Okay, so you make a payment here, maybe payment here, payment here, payment here, payment here. And let's say that the compounding events also happen with the payments, right? If I ask you what the value of the loan is here, you compute the present value of all of these payments, right? That's the value of the loan. If I ask you what the present value of the loan is here, then you compute the present value of these payments. If I ask you what the present value of the loan is here, you compute these payments, right? So the present value of the loan, the value of the loan is always the present value of the remaining payments of the loan. Okay, does everyone get that? Does that make sense now? So if you're asked that sort of question, that's how you do it, right? That one you just need to remember, right? The present value of the value of the loan is always the present value of the remaining payments. Okay. Oh yeah, absolutely. And I was trying to emphasize that day one, timeline, right? Like, if you want to see what's going on, you got to have things in your head as a timeline. And that's the same thing for the assignments, right? For those of you, because I know in the chat, some people are talking about trying to work on those assignments. Same sort of thing, timeline, right? Make sure that you can draw. Oh yeah, they make a huge difference, right? They make all the difference in the world. Even just in terms of like your intuition, not just solving them, but like actually understanding what's going on and being able to just see how money is moving makes a huge difference, right? It's very, very valuable. Ooh, jump too far again. Okay, here's one. This one, if you want to do a sort of competition thing, it shouldn't take too long. Oh yeah, definitely show a timeline on your assignment. Curdy, do you remember remember when we were doing the writing assignment and some of the advice was like draw a picture? That would be a timeline as a picture, right? Like that would be a visual aid. to help someone. Now, it can't be the totality of your work, right? You're using it as an assistive device, as an aid. It's not, it doesn't count as work, but it's a super valuable thing if you want to demonstrate your understanding. Yeah. Can there be too many words on any assignment, Jacob, not just a writing assignment? Absolutely. Okay. And everyone, this is, I think, a really important point. So do the poll question first and then listen to me. Your goal always, Jacob, is readability, right? And you can imagine that if you give someone a solution that's too detailed, then it actually becomes less readable, right? Because like if I go into every small little thing and the assignment becomes, or the solution, let's say I produce a solution and it's like 3 pages long when it only had to be a half a page, that's not very readable, right? In fact, it's easy to forget what it is you were even trying to do halfway through that document. So it's definitely possible to have too many words. So your goal is to find that nice space in between, right? Where you've explained enough, but you don't have to explain any more. And there's a spectrum, right? There's like a range where that's appropriate. And so it's not like there's a perfect length, but you're just trying to find, get yourself somewhere in between there where people can read it and really understand what you're doing, but you haven't gone into crazy detail, right? Right. And so, Jacob, again, here's an important thing, especially when you're doing computation, you don't have to like include every single detail. Details which are obvious don't need to be included, right? So let's say, for example, you get an equation and it's something like, 4x, plus 7 is equal to 15. You don't have to do the algebra. You can say 4x plus 7 is equal to 15, so x is equal to 2 or whatever, right? Don't do all the steps there. You can reasonably assume that whoever's reading your paper knows how to do that algebra. Do you know what I mean? Versus doing like, let's subtract 7 from both sides and then divide by 2, so x is equal to whatever. That's too much, right? Like you'll find that range eventually, but if you're not certain, give it to a friend or post on Piazza privately, and we can tell you if I think it's too long. I definitely had a student who posted something on Piazza and asked for some feedback, and I said, it's good, I like what you're doing, but your answer is too long. Like, I don't need this level of detail, right? So you'll find it too. Right? No, you post on Piazza, but you post it privately. You can ask me anything. Okay, you can't show your stuff to your classmates, but you can ask me anything. And the worst that could happen is I just say, I can't answer that, right?
The key is to make it private. You don't want to like post it public, right? So just double check before you do so.
Right, on Piazza, you can post things so that only the instructors can see. And in that case, we can then give you feedback that way. All right, we're at 70%. Let's do another 30 seconds or so. Yeah, I'm sure that's terrifying. Don't worry, during a test, so Piazza is the best way as well to ask questions during the test. And during a test, I will set it so that you can only post private questions in Piazza. And then you can't even accidentally do it, because that's really where you don't want to get an academic offense. And I did have to tell a few people for assignment 1, they accidentally posted publicly, and I had to make their post private and then give them a little, I was like, I'm not going to pursue this now because you just don't know any better. But, if you do this in the future, it will be an academic offense. And they're like, oh, geez, I'm sorry. And I believe them. I don't think they were trying to, post, trying to get an academic offense. So when that sort of stuff happens, we usually just make it private very quickly. But, avoid it if at all possible, right? You can ask anything during a test, right? Here, let me take this up, and then I'll do some more like what can you ask during a test, because there's an important lesson that I want you to have there. But let me take this one up first. Okay, so we're leaning towards A a little bit. Well, nobody answered D this time, so that's good. Right. Okay, so A is correct, and a little over half of you said A, so that's great. This one is just straight up. We can just do this with computation. Okay, so this is question 9. Okay, and what does it say? So, oops, I don't have my right question up here. So 2 perpetuities, they both pay out $1,000. So they both pay 1,000. Okay, account A is a rate of 2%. 2% monthly. B is 5% monthly, which is bigger, which has a bigger present value. Okay, somebody tell me, what is the present value of A? This one's just straight up computation. Yep, exactly. What's the present value of B? Sure, yep. If I were to like not do out the calculation, but you're absolutely right. So you guys can work this out. Which of these numbers is bigger? A is bigger, right? Whatever these work out to be, A is bigger. Right? Now, what if I didn't give you $1,000? What if I said it was some principal P? Right? And I got, and for the record, I think this actually was a test question one year. Right? How would you argue this one now? So this is still true, but how would you explain this on a test? Say, what would you do? What would you say to me? What words would you say? And there's both a financial answer and a mathematical answer, and both are valid. Smaller the R, bigger the present value. Okay, yeah, so Sylvia, that's actually the financial answer, right? The smaller the rate, the smaller the discounts, and therefore the higher the present value, right? So that's the financial answer. Since its present value, lower rate means greater value. Chen, exactly the same sort of thing. Yeah, it's great. And Louisa, you said the same thing, right? Only used which one was smaller. Absolutely. And then, yeah, so yeah. And Christian, you have the math answer, right? And as the interest rate approaches present value, oh, that's an interesting one, Brandon. So as the interest rate approaches 100%, the present value will approach P because the limit of the present value is P over 1. Therefore, the smaller denominator will give the highest. Okay, yeah. So Brandon, yours is an interesting like mix of the financial and the math answer, which is kind of cool. I like that. Christian's answer is the math answer, right? PVA is dividing by a smaller number, right? And we know that, you know, when you divide by a smaller number, the overall number is bigger, right? If you divide by a big number, your answer is small. You divide by a small number, your answer is big. So because 0.02 is smaller than 0.05, the answer on the left is bigger. Now, here's the actual way this question was stated in that test. It was if RA is less than RB, you know, is PVA bigger than PVB, you know, equal, or was it greater, equal, or less than? And all of your answers are still 100% correct, right? It's just that we removed whether it was 2% and 5%. We just told you one is an answer R sub A, one is an answer R sub B. And exactly the same thing would apply, right? You would say, look, RB is the bigger rate, so it has the higher discounting, and so it has the smaller present value, right? Or you would say, look, when I compute PVA and PVB, then PVB is dividing by the bigger number, so it must be the smaller of the two accounts, right? Reasoning is totally fine. Yeah, right? As long as you write those words out, that's a perfectly great answer. And in fact, I think we said, like, in 2 or 3 sentences, explain which of these is bigger. You can use a mathematical answer or a financial answer. Either is fine, right? I would want you both Where was that PV formula? It's in the perpetuity formula, or it's in the perpetuity section, but it's like R P over, I think it's written as R over R in the notes. If somebody knows where it is in the notes, like if they can just post it in the chat, because somebody in a direct message asked me. But yeah, I mean, that's a great question, I think. And I want you all to be able to explain both, right? I don't think the mathematical answer. So first of all, I love how many of you gave a financial answer. Like that's phenomenal. I really love that. For those of you who gave a financial answer, I want you as well to be able to do the math answer. And for those who gave a math answer, I want you to be able to do a financial answer as well, right? Generally, I'll only ask for one, but the more tools you have in your toolbox, the better, right? The better all around. Okay. Before we go to office hours, I'm not going to do another poll question. What I want to do instead is I want to do an open-ended question. Okay. And so basically, I'm going to give you a couple of minutes to work on it, and then I want you to, we'll go over it, and you all can throw in your chat what exactly your answer would be. And this is very related to the sorts of things that we did on Tuesday. So especially for those of you who hung out for office hours on Tuesday, we did a lot more of the problems that we were doing at the end of class. Now I want to take that one step further, and I want to apply it to a perpetuity. Okay. So let's say, consider the scheme. Okay, so let's see. So we compound at a rate R on Monday, Wednesday, and Friday. We invest, or we make payments out of a perpetuity on Sunday, right? So notably, that's the beginning of the week, right? So if Sunday, well, let me say that explicitly. So if Sunday is the beginning of the week, what's the value of the perpetuity? Okay. Payments on Sunday, so at the beginning of every week, and then we compound at the rate R, Monday, Wednesday, Friday. This is our perpetuity scheme. What is the present value of this perpetuity? What, lecture time went by real quick? I hope that's just because you were having such a great time. Right? Time flies when you're having fun. Yeah, when did you ever think you were going to say math was your favorite class, right? Like it's okay. Well, that's awesome. No, I love that. Yeah, high school math again. Part of the problem is you got people who, one, don't want to be there, and two, people who actually don't really understand math well. Don't get me wrong. I'm certain that there are high school math teachers who are good at math, but a lot of them don't need to do a lot of math in order to get math as a teachable, right? So that's something to be said. Oh, really? Thank you. I it might seem silly to be happy that you like my Quercus layout, but I worked hard on it. So I wanted it to be kind of organized and easy to get things. So I actually did spend some time on that, right?
No, out of experience, I would say your Quercus tends to be one of the better ones I've ever seen. So
thank you. Yes, that's good.
And I've seen a lot of them. So
right. And Ahmed, I spend time spouting sarcastic comments about all of your former math teachers. Well, okay, so Louise, and I know it's a direct message, you say this, but you should see a proofs course, because then it's not a correct answer anymore. It's a little bit more open-ended.
Oh, the 1 + 1 = 2, I'm assuming.
It was just more that like math has a right answer.
Oh, okay.
But once you start doing proofs, like that's not as clear anymore.
Because I remember I took proofs with Professor Shai Fuchs, and one of the first classes, he put the 1 + 1 = 2 on the board. He's like, "How many of you guys think this is correct?" And obviously everyone raised their hand. He's like, "Well,
And then you put it in Z2.
Yeah, and then he put it in a field of elements of like 0, 1, X, and Y, and he's like, "This isn't true anymore."
Yeah, I put it in a field of characteristic too, just to screw with you.
Yeah. So he's like, "Yep, exactly. Not gonna go well for you guys here."
I mean, so Brandon, proofs is real math. And I don't know how to explain this. I mean, obviously I'm a very biased source, right? Like I love math. And I always have, but math is often like astronomy, right? Like I love astronomy. I think like learning about neutron stars or black holes or the planets of the solar system, that stuff's super cool. You look at the pictures of those things, or of that, what was that thing that landed on the comet, right? Like so cool. That stuff is so awesome. And then I started taking astronomy classes in my undergrad, and I was like, this is terrible. This is like the worst thing in the world. It's one thing to like look at, like learn about things in a high level, but when you start actually doing the nitty gritties, it became a lot less fun. There's a very real sense in which math can be like that. Now, I'm not going to say it is like that, but it can be like that. There's lots of really cool things that I can tell you about math. But once you get into the nitty gritties, you're like, oh, no, thank you. But there's so much actually like really, really fun, really cool stuff that is very easily accessible. That's something that a proofs course would show you. It really develops your critical thinking skills. That's the whole point. That's why we make people take a proofs class, right? Do we ever do Taylor series in the course? No, but it is actually in the books. So if you look at, there's a section at the end of chapter, I don't remember which one, whatever the derivatives chapter is, there's something in there called polynomial approximation, and it will talk to you a little bit about Taylor series. But yeah, we don't go into it in much detail here. Okay, everyone. So did anyone manage to get an answer for this? Because I'm happy, just to mess around with you all, but this is an important question. And I want you all to make sure that we got it. Okay, so I want to make sure everyone's okay. Okay, yeah, Ariana, I like it. I personally would start the sum at 0 though, but otherwise, exactly, you nailed it. And then did you try and put that into the infinite geometric series? Like the formula for it? If not, I want you to do that. Just take like a couple of seconds and try and write it out. Let me remind you what the formula is. And if you don't see why the sum starts at 1, I'll do it when I pick it up. Oh, yes, thank you. Yeah. So this is going to be A over 1 minus R. Okay, so if you got the sigma notation, anyone who got the sigma notation, just take a second, plug it into this formula just so that you get the final answer. And then I'll take it up and make sure that we're all on the same page about it. Okay, so hopefully you've had a chance to do that. Now, I'm going to take this up. As always, first thing I'm going to do is draw a timeline, right? Because you can't go wrong. Timeline is your key to success always. Always, always, always. And again, I'm not going to draw in every day of the week. The only thing that really matters is that there are 3 compounding periods in each week, Monday, Wednesday, and Friday, right? So I guess these are going to be my payments P. And then these are going to be my compounding events at R. Okay, I don't want to put a little R above them, but hopefully you're all okay. If you see a blue line, that is a compounding event. Okay, that's all right? Does everyone agree this is the timeline? We've got a week. At the beginning of each week, we have a compounding event, and then we have 3 compounding events during the week. Now, I want to bring all of these, it's a perpetuity, so I want to find its present value. So I want to bring all of these values back to the present. The first thing I'm going to get is this thing right here. This is the P, and Ariana, this might be like, you might have just missed this P, but this is why the sum starts at 0. So this is an easy one to miss, but yeah, so in this case, I am actually going to say that this payment occurs in the right at the beginning, and so our sum is going to start at 0. But that's a very reasonable thing to miss, because you might say like, well, then, why even put it there? But anyway, if I bring this one back, what is the value of this payment when I bring it back to the future, or to the past, sorry, to the present? How many compounding events did I go through? Right. And yes, Curdy, I think you must have probably made a little typo there, just because there's like a subscript there, but exactly. So yeah, it's to the power of -3, right? Because I went through 3 compounding periods when I came back, right? Okay, let's just do a couple more. How about this one? How many compounding events did this one go back through? 6, right? Exactly. Everyone okay? Is anyone freaking out about this? Because if so, again, say something and I can go a little bit slower. Let's just do one more. Oh, look at you all. You're kind of like you anticipated and had it in the chat before I even did it. Okay, so Jack just trying to beat the thing. I like it. Okay, so the value of our perpetuity, right, is going to be P plus P times 1 plus R to the -3 plus P times, and this goes forever, right? This is actually an infinite geometric series. -9, and then for Jack and Caitlin, yeah, the chat's just very quickly going to be you all counting, right? Counting by -3 upwards. So in order to be able to, yeah, you can all keep going. Now, in order to put this into an infinite geometric series, again, what we're going to do is we're going to look at the common ratio. And remember, if you want to determine the common ratio, all you have to do is you can take any term and divide it by the previous term. Okay, and if I do that, I'm going to get a common ratio. I mean, there is a P, that's not part of the common ratio, but I get a common ratio of -3. Okay. Oh, Sylvia, like, come on. You knew exactly what question I was going to ask. I love that you beat it. But yeah, let me repeat it. Okay. So the common ratio, you take one term and you divide it by the previous one. Okay, so I'm going to take this term, P1 plus R to the -9, and I'm going to divide it by the previous term, 1 plus R to the -6. The P's cancel, and I get 1 plus R to the -3, like that. Okay, and that works for any term. If you did it with the -12 and divided it by the -9, you'd get the same answer. If you did it with the -6 divided by the -3, same answer. If you do, if you want to find the common ratio, you can do it anywhere along that. Okay, right. Why is it K equals 0? So I'm getting a bunch of these. And yeah, okay, everyone, this one's really, really important. Why does this one start at 0? So we know here that we want our exponent to be -3K, okay? And the very first term, this thing right here, this is the very first term. So what we're going to do is we're going to look at the first term, and we're going to say, what value of K, and there's lots of great advice in the chat as well, but what value of K turns this into just P, right? And the answer is K equals 0, because then if I have 1 plus R to the power of 0, that term just all becomes 1, right? And this term here, so this is K equals 0, right? This term is going to be K equals 1. This term is K equals 2. Does that make sense? Do people see it? Is good? all perpetuities are all regular perpetuities are infinite geometric sequences, right? And I got, so like, for example, if you think about the assignment question, that's like an annuity, like question 1 of the of assignment 2, that's like an annuity, but the compounding periods aren't regular. And so it's not actually a geometric series. Here, because everything is repeating and at regular intervals, it is an infinite geometric series. But again, I want you to be careful about internalizing that pattern. And the moment you see perpetuity, just assuming it's an infinite geometric series, it's more important to understand the principles in case I decide to throw you a curveball, right? Okay, no, wait. So the top value is, it's an infinite geometric series. So there's no final value of the series, right? So the top value here is actually going to be infinity, right? Because this series goes on forever, right? Can we factor out the P? Absolutely. So I got a private message of somebody asking, can we factor out the P? Absolutely, you can. And so if you want, you could have written it like this instead, and it would have been the exact same answer. Okay. But so I got a private message. So, but then when you multiply -3 times 0, since K 0, right? Like here, I could have written this instead as maybe 1 plus R to the 0, like that. Does that kind of help it make sense, as we can see why the power of 0 is there, right? So if you want, anytime you see that constant there, replace it with a 1 plus R to the power of 0. That might make it a little bit easier for you all to set up the geometric series. Okay. Can you explain why it starts with P in the timeline? Sure. So this was week 1. Right, this is week 1. And we said that the week starts on Sunday. And in the question, I said we make payments on the Sunday. So if the week starts on Sunday and our first payment is on Sunday, then our first payment is right at the beginning of the timeline, right? And yeah, exactly. And Aziz, thanks for getting in there. So the first payment is already in the present, right? The first payment I make is today. So because today is the Sunday of the first week, so to bring it back to the present, I don't need to do anything. It's already here. Okay. And then if you all want to like take this and throw it into our formula for an infinite geometric series, you're going to get, I guess I've been using yellow here. So you can get P divided by 1 minus my common ratio, like that. Okay. And as far as I'm concerned, you can leave it like that. If you want to do a little bit of further simplification, you can, but that is a perfectly fine answer as far as I'm concerned. Okay. Is everyone good? That makes sense? Now, as an exercise, what I would like you to do is consider the following. Okay. And you can do this on your own if you like, and then ask me if it's correct. What if exactly the same problem, but now instead of making the payments on Sunday, I make them on Saturday? Okay, so the first payment is at the end of the first week instead of the beginning. And what I want you to do is to figure out how that changes the answer. Okay, so actually, maybe let me write down a couple of possible things. So here are ways, if you want some practice. Practice 1, change the payment to Saturday. Okay. 2, only make the payment at the beginning of every other week. So let's say keep the payment on Sunday. On Sunday, but only every 2 weeks instead of every week. Okay. Yeah, so Aziz says you should evaluate the sigma, unless the only reason not to is if I say just write it as a sigma, right? If I say you can just write down the sigma, then that's fine. Always trust the instructions on the test. Usually the instructions are unambiguous, but as Aziz says, as a general rule, you've been taught how to do this. So, but if you get to there and you mess up the final step, you got most of the marks, right? Yeah. Okay, so I want you all to, again, if you want more practice, do them. You know what? Yeah, number 3, Curdy, on basically your request, combine 1 and 2.
That's how you get extra homework on that.
That's how you get extra homework. That's right. But no, this is exactly how you practice, right? Everyone, this is how it's done. And like I was saying to you all at the end of Tuesday, and for those of you who hung around for those office hours, so many people were asking great questions because they were asking, like, what happens if I do a little twist? What happens if I just change the problem a bit? How does that change how I attack the problem? And that's exactly what you should be doing. That's next level studentry. That's how you become a next level student, is you take stuff that we've done in class and you say, well, what happens if I make a little bit twist? Now, what I said in that class, which possibly not everyone heard, was your first instinct is to come and ask me, right? Your first instinct is, well, what if we made the payments on Saturday? How would that change the answer? To really do the next level, not only ask the question, but then try to answer it yourself. And then if you can't do it because you get stuck, you come to me and you say, I tried to answer this question, which is similar but different, and I got stuck here. Can you help me? And every instructor, I think every TA will be like, yes, we would love to, because that's the best sort of thing that a student can come and ask you to do. And that's a very exciting thing as an instructor to see. So here, I'm going to try and push you in the right direction and say, here are 3 twists to this question where the technique that you're going to employ is almost identical to what we've done above. If you can do these 3 things, you understand that example 100%. And you should be able to do any other example I give you, right? Another twist might be, no problem, Faiza, see you later. Another twist might be to, instead of doing R on each of Monday, Wednesday, Friday, change them to R, S, and T or something like that, right? That's great practice, right? Change them to R, S, and T and see if you can do it when the interest rates are different. The technique is almost identical, but if you can do it with a twist, then you'll be confident that no matter what twist I throw at you on a test, because you imagine I'm not going to give you exactly one of these questions, it's going to be a little bit different. If you can handle any twist that you make up yourself, you can probably handle anything I'll throw at you, right? So that's how you get next level. That's how you practice and get good. All right. Yeah, I don't see why not. Yeah, you should totally be able to write it as a single sigma. Yeah. Okay, so for all those who want to take off, absolutely, you're free to go. You're free to run away. Technically, right, you should use this time to watch next week's videos, which have been posted, but of course, you do what you decide you want to do. Otherwise, I'm going to hang around. These are my office hours right now. Aziz, it's entirely up to you whether you're hanging out. I don't know if you are.
I'm heading out this time around, but
for sure.
Yeah, I'll be around probably longer next week.
All right, sounds good, man. See you later.
See you, everyone.
And Connie, yes, every Saturday. No. So every other Saturday. So when I say combine 1 and 2, maybe do like every other Saturday, right? So all the payments are on Saturday. But hey, listen, keep throwing twists into it. What happens if there's a payment on Saturday and Sunday? Right? If you want a really hard question, what happens if in week 1 you compound 3 times and in week 4 you compound 4 times? And then in then you repeat that 3 times, 4 times, 3 times, 4 times, 3 times, 4 times. That's a much harder question. It's definitely still doable, but it is a harder question for sure. And I mean, like when I say harder, I think it's harder just because we haven't done much like that. I think actually one of my weird annuity questions has something like that in it, but it's something that we haven't practiced a lot. So for that reason, it's harder, but it's actually not that much worse. It just requires that you remember a little something extra about sigma notation. Am I going to take what up after these 3? I had no plan to, but if there's enough demand, say at office hours on Tuesday, then we could definitely take it up. Still have P at the beginning. It depends on the scheme. That will definitely change. Dowd, in Sigma, can you use K different spots? I'm not certain what that means. Can you elaborate on it? Okay, well, Jack, write it out. Jacob, which question from earlier? Discuss with the sum. Right, when you're not geometric. Yeah, okay, sure. Yeah, let me do that. Jacob, I wonder if that's what you were asking about. But in any case, let me start with that, okay? So if I give you a sum that isn't a geometric, writing a summation with random R payments. Okay, all right, so it's basically the same question. Let me give you something first. What if I gave you the following series? Okay, and I said, I want you to write this in Sigma notation. What would you do? Okay, try it for a second. Spend 30 seconds or so, see if you can figure it out. Would it just be P for the first week? Isabella, no, you would actually, because for the first practice, you would come back through 3 periods, right? So it wouldn't just be P, you'd get compounding events. And soon, yeah, we can do a similar problem to the assignments. Okay, so Curdy, be careful here. This is not a geometric series. So in this case, we don't just want to take a common ratio because it won't work, because this isn't geometric, right? And I can see that because if I take this and divide it by that, what do I get? I get 3. But if I take this and divide it by this, what do I get? I get 5/3. And if it's geometric, those numbers need to be the same no matter what pair I take. So you can actually determine whether a series is geometric or not by taking any 2 subsequent terms. They must always, when you divide one term by its previous term, must always give you the same answer. Yeah, phenomenal. K times K plus 1. Exactly. Okay. So phenomenal is equal to K times K plus 1, right? That's the pattern, is that it's a number times the number plus 1. Does everyone agree? That's what the pattern here is. It's a number times the next number. Is everyone okay? And then we'll figure out the bounds in a second, but let's make sure that everyone's comfortable. Okay, everyone's comfortable with that? Okay. What value of K gives us 1 times 2? That's where we're going to start. Okay, Namir, very quick. Kurti, perfect. Yep. All right, you all agree it's 1? Is anyone not okay with why it's 1? And then 1 to 6. Okay, yeah. You guys are just flying. But okay, everyone's okay with 1? Right? And then the value of K, which gives you this, is what? Right? Exactly. Everyone agrees it's 6. Boom. That's how you do sigma notation. Yeah, exactly. And a 6. But this is not a geometric series, right? You can't use the geometric series formula to simplify this anymore. There is a formula to simplify this, but you don't know what it is. Okay. KR 1 plus R and then an exponent after. Right. But Dowd, really be careful here because you are very close to giving away an answer in the chat, right? So that is, you're on the line. Make sure you send that to me directly, right? Very close to an academic offense. Again, I know you're not trying to do it on purpose, which is why I'm giving you the warning, but just be careful, right? Be careful. Can I explain why the 6 again? Sure. So I got a direct message asking why the 6 again. What I want to do is compare this, and let's actually just write k times k plus 1 under here. And I'm trying to figure out the value of k, which makes this 6 times 7. And if I write k times k plus 1 under here, can you see which value, direct messenger, can you see which value of k gives me the last term? And that it's k equals 6. Right? And so does that make sense then? That's where the 6 comes from. So, okay, no problem. Does everyone see then, if you wanted to do, for those of you who have like gotten question 1.1 to a point where you've written it out as you know, something plus something plus something, the sort of technique you would use in order to write it as a series if you want to. It's not geometric, but if you want to write it as a series, which is not necessary, this is the sort of thing you would do. You'd look to try and see the pattern, and then you try and figure out what the bottom number is and what the top number is, right? And that's how you set up sigma notation. You want another one? Do you all want another sigma notation like this? Okay, another one. Let's see what I can do. Maybe I can make this one maybe a little bit trickier. Okay. All right, yeah, actually here. And let's maybe stop at 13. Brandon, yes, you can leave it as the long sum if you want. Jacob, yeah, with an R value. Give me a second, I'll give you an R value-ish thing. Can you give us an answer for the second problem, 2 week with P1? Hold on, let me see. Keep the payment on Sunday, but only every 2 weeks. So Sylvia, the answer is that everywhere there's a 3, you'll now get a 6. Okay, so anyone, what's the pattern here? It's definitely the odd numbers, right? Okay, k plus 2 does that. Okay, that's a really great start. So we do k plus 2. What value of k is this one? Okay, wait. So you're all telling me that if I plug k equals 1 into k plus 2, I get the number 1 out. Okay, so some people are saying, Agam, yeah, you are right. Okay, but let's say -1. Okay. What's the next number after -1? Right, we plug in k equals 0. What does k equals 0 give me? And is 2 in the list of numbers that I'm adding? It's not, right? So this is not the right formula, but a couple of you have a hypothesis. Let's try yours. So some people have suggested doing this. Okay, so let's try this one. Notice what this is saying. It's saying that because it's 2 times k, it's saying that every time I increment k, the number here is going to increase by 2, right? This is the other way of doing an increment by 2, is by putting the 2 in front of the k. So what value of k would give me 1? Okay, 0. Everyone agrees 0? Does that make sense? Okay, and does this work? Let's double check this. Now, if I plug in k equals 1, do I get 3? And then if I plug in k equals 2, do I get 5? And it seems to work, right? Okay, where do I stop? What's the last number? What's 13 as 2k plus 1? Right, it's 6. Okay, now, and in the direct messages, okay, so is everyone okay with that? So that these two things are equal. Now, some people in the direct messages wanted to do it, and not direct messages as well, I saw you all. Some people wanted to do it as 2k minus 1 instead, which I love. Let's see if this also works. if I used 2k minus 1, where would my index start? What is the value of 2k? What is the value of k, which makes 2k minus 1 equal to 1? Great. Yeah, perfect. K equals 1. What is the value that makes it? And yeah, Louise, I don't know you, but you keep direct messaging me. So I don't know if you mean to. It's okay because I can see it, but like not everyone can see it. And exactly 7, right? So like you guys are killing it, right? You guys have nailed it. So this is how you do these sigma notation things. So does that make sense? Like usually you just you guess a pattern, check to make sure a couple of them work, figure out what the first one is, the first k, figure out what the last k is, and boom, you're good to go, right? Oh, I see what you're saying. But this isn't an assignment question, Louise. So you can just say it, right? It's okay. So does everyone see how you do that? Is that good? So same sort of thing, right? With question 1.1 of the assignment, you do exactly the same thing. Okay, let's discuss the assignment things. What about the assignment things? I'm just gonna open my window a bit. It's getting really hot in my room. Let's get a little breeze. In the yellow text, it would be the same to put the k outside the brackets on the left of the sigma. So you want to put like k out here and do something. Okay, so note that when I write a sum like this, k doesn't mean anything outside of the sigma notation, because notice how there's no k's up here, right? There's no k's in the original sum. So the k only makes sense in the context of the sigma notation. And so if there's any k's, I can't take them out, right? But what I could do, and you're kind of onto something cool here, is I can actually split this up. I can split this. I could take the 2 out because there's no k's involved in that. And I could split this up like this, right? So I could do that if you really wanted to. Okay, but there's different values of p. So how would that be done? Well, so Jacob, you would do it in exactly the same way. Like there's only so much I can say, right, without giving stuff away. But yeah, p is a constant. And so look at the terms of the series and try and figure out the pattern, just like we did here. Like what if it was 1 plus 3p plus 5p, or let's say p plus 3p plus 5p plus 7p plus 9p. You still, I believe you could have done this problem with these p's here. It doesn't really change anything, right? P is just a constant in the problem. You can just like kind of pull it out. So does that make sense? Like, and Jacob, yep, exactly, that's true. And you notice the p's there don't make a difference, right? The p's don't affect anything. So set up the same system as we just did in sigma notation and try and guess the pattern and then figure out the first k and the last k if you want to do it that way. On the k outside the brackets, can we make it 3k or like any number? Like, okay, so are you asking like, if that's equal to 10 times that? Is that what you're asking, Abby? Like whether I can take that 10 out? No? Okay. On the k, that's, yeah, sure. And soon I see your problem. Just, no, you don't need to put it in sigma notation. You can leave it as just a sum if you want. You mean like 3k, k plus 1. Like up here, you want this one to be 3? And then, yeah, you can take that 3 out if you want. Or are you asking if we can do the problem with a 3 in here? Okay, so if you do the problem with a 3, what value of k makes this equal to 3k times k plus 1? Right? And the answer is there isn't one. So in this case, like, even though sometimes you can change what the summand is and then adapt, in this case you can't, right? Because you still need to have a pattern which makes sense, right? Yeah, okay, so there's a couple things here. Can we do a question whether there are regular periods of payments and have an answer in a sigma? So the thing is, if I do that question, it's if I even like something similar, it's very, very close to what's happening in the assignment. And like basically if I did it, it would really give the assignment away. And I'm not certain that I'm comfortable doing it. But let me see if I can think of something else. Yeah, I mean, 48 people is a lot of people to give an unfair advantage to, right? All right, hold on. Let me think of something. I've also got a bunch of direct messages, so let me read them too. For annuity, the value at the end of the period is basically the principal times their compounding events. Yes, right? So you always just push them forward. For the assignment, if our explanation of our work was spot on, but the actual answer is wrong, how many marks do we get? It depends. Like, it's impossible to say. It's going to depend on, you know, like if your explanation is perfect and all of your work is perfect and you just script the final answer, you should get everything but one. You might even get the full marks just because we're like, yeah, you just made a dumb mistake. But it depends on the nature of how, like, if your explanation is spot on, but your answer is wrong, why is your answer wrong, right? It's going to depend on that. And right, listen, everyone, I did promise to answer this question as well. And here's what I want to ask. Here's something that I want to say, okay, that isn't related to the assignment directly or the test directly. If you're ever uncertain about something, for the love of God, ask. Okay. If you're not certain whether something is an academic offense, ask. If you're not certain that you're interpreting a question correctly on an assignment or a test, ask. The reason for this, like, think about it like this. If what I'll often have is sometimes students will get a test question and they'll answer it wrong. And they'll come back to me after and say, yeah, I just misunderstood what you were trying to ask. You know, I wasn't quite certain. So I made a guess and I assumed that this is what you meant. And I went ahead with it. And I said, no, don't do that. Ask me, because in no way do I want you to get a question wrong. Like, if you get a question wrong, I want it to be because you didn't understand what you were doing, not because you didn't understand what I was asking, right? So at any given time, always ask. And I will never be upset at anyone for asking a question. I might not give you an answer, and I certainly might not give you the answer that you like, right? But there's never any harm in asking the question in the first place, right? Because, but I promise you, if you ask, sometimes I'll answer, but I also promise that sometimes I'll say, I just can't do that, right? I can't answer that question. Okay. But if that's the worst case scenario, if the worst case scenario is me just saying to you, I'm sorry, I can't answer that question, then what do you have to lose? Right? Okay, so like if we use the wrong method, but explain the method very well, again, it depends, right? It depends. Like, you could explain super great, but just do the completely wrong question. And there's only so marks you're going to get from that, right? There are a certain number of objectives that we're looking for you to achieve, and your mark will be based off of how many of those objectives you achieve. So a brilliantly written explanation about a problem in management that you submitted for your math homework is not going to get many marks, right? Will the term test include bonds? No, but I'm going to post something tomorrow that will explicitly state what exactly is on the test or not. And I'm going to do another question here with something maybe a little bit more irregular. I'm trying to think about it, but I'm also being inundated with questions. I have a question for the perpetuity question. If we change the payments on Saturday, does that mean the same result with the previous thing? But if we want to do every 2 Sundays, which is going to be that, combine the two of them, just have two sigma notations? No. When you combine them, I'm saying you want the payment to be on Saturday, but only made every other Saturday. So maybe the first Saturday, the third Saturday, the fifth Saturday, and like that. And it should only still be a single sigma notation. Moreover, when you change the payments to Saturday, you will not get the same answer as your payments being on Sunday. It will be very similar, but it will be a different answer. Okay. For question 2 on the assignment, what does it mean they refuse to divulge the value of R1? It means they're not telling you what that interest rate is. They're going to tell you what the effective annual rate is, but they're not going to tell you what the actual rate is. So you have to figure out what the actual rate is from the effective annual rate. Okay. Well, having too much explanation to deduct marks. In the early days, especially, we're very sympathetic, but as a general rule, don't write us, long paragraphs. Take a look at the sorts of things that we've given you in terms of assignment problems or assignment solutions, in terms of the solutions in the book. Those are probably too long for what we expect from you, right? But still give you sort of an idea of how much words should be included. You'll notice that in the in the book, I don't go into crazy detail, right? I give you enough detail to hopefully understand what's happening, but not, I don't spell out every single algebraic move. For the second practice question, I got this. There shouldn't be that second P in there. Direct messenger who said P divided by 1 minus P 1 plus R to the negative 3, that second P shouldn't be in there. And yeah, Connie's still not adding. Yeah, you don't want to add them. There will be a single sigma notation. Can we do a practice problem like what we can expect on the test? I like the adding, or I like the asking. The answer is no. I mean, because that would be in some way me divulging what's on the test. If you want to do a practice question similar to something you come up with, absolutely. But I'm not going to divulge any information about what's on the test because it would be unfair for you all to know and for nobody else in the class to know, right? That would not be fair. Can we work on something similar to question 2 of the assignment? And now I'm getting question 1 of the assignment in the sequence. Brandon, yes, you can absolutely factor that out. Oh, I see. Yeah, you weren't trying to say ass. Yeah, 100%. Let's say I get a step to require a calculator just to save space. Can I include the final answer? Depends on what you mean. You can expand that out. And Isabella, even without that P there, I still don't think it's correct. Okay, let's do something truly. A bunch of people are asking for a question 1 like example and a question 2. Let me come up with something, but it's going to be similar, but not so similar that it gives away the assignment. Okay, so let's say, okay, all right, 30 days, half September, April, June, and November. So January is 31st, 31 days. I think, right? Let's say we make a payment on January 1st and January 15th. I actually think this was a final exam problem a couple of years ago. Oh, Jacob, it doesn't matter. I don't even look at the folders. Just choose something. So January 1st, January 15th, interest is applied as follows. Well, let's even do something weirder. January 25th. So R% on the 3rd, 10th, 18th, and 27th. S% on, I don't know, let's say 15, 19, and 30. Okay. Yeah, this is supposed to be a similar question like homework 2. Okay. So here's a crazy scheme. January is 31 days. I told you I make payments, let's say payments P dollars on January 1st and January 25th. I apply interest R% on the 3rd, the 10th, the 18th, and the 27th, and I apply interest S on the 15th, 19th, and 30th. What is the future value? At the end of January, what is the value of the account? Okay. Now, if you want, timeline this. Actually, you know what? I want you to take a second. I want you to try and do this yourself. This is a 19. Let me try and make that a little bit more clear. Yes, yeah, those are the dates that the interest is applied. Let me see. Connie, yes, exactly. Yeah. Well, that's good, Jacob, then, right? Like, then if we answer this, you'll be able to get it, no problem, if you don't already have it. Dog, yes. Yeah, that's correct. You very close, Jack. Very close. Oh, not okay. You don't want the two. Both, you don't want either of the twos in your expression. Neither of those is supposed to be there. It's very close, though. Very close. Brandon, you are missing a 1 plus R in your first one, right? Why is there only 3? That's right. But that first payment sees all 4 of the R's, right? S is just some interest rate, Jacob. It's like 5% or 10% or something. Yeah, I think you just miscounted Brandon, right? Okay. Let me take this one up. This is one I think you can do, Jeremiah. Perfect, beautiful. And Jacob, yeah, they're different rates. Group R tap, close, very close. But yeah, you need to add another term in, and you don't want the 2. Okay, let me take it up. Timeline. Okay. Now, again, you might be able to do this without a timeline just by figuring out how many compounding periods each payment goes through. But if you're not certain, use a timeline, right? Okay, so here's my month of January. And again, I'm not going to give it like 31 slots, right? I'm just going to eyeball it. So there's a payment on the first day and there's a payment on the 27th day, right? I'm going to say this is the 27th P. This is the first right here. Okay, what do I got? I got 3rd, 10, 18, and or sorry, it's paid on the 25th, right? I'm sure somebody's yelling that at me in the chat that I just haven't seen yet. Am I right? Yes, perfect. Exactly. I knew someone was yelling at me. Okay. So 3, 10, 18, and 27, and then 15, 19, and 30. Okay. Everyone's good? So I'm going to take my first payment P. I'm going to push it all the way to the end of the month. How many blue things does it go through? Goes through 4, exactly. So I get 1 plus R to the power 4, and then 3 green things, exactly. 1 plus S cubed. Everyone okay with that? Does that make sense? You're just counting, right? The number of compounding events that your payment P went through. It went through 4 events at the interest rate R, and it went through 3 events at the interest rate S. So it picks up these things. It's good. Are there any questions about that? Hopefully that's okay. If you're typing, just keep typing. This payment, we push it forward. How many? Yeah, it goes through 1 of the blues, and then how many of the S's? 1 as well. The total value of the count at the end of that period. Boom. Now this one you can't, like, this one's not worth writing in segment notation, right? There's just, first of all, there's only 2 terms, and there's definitely not enough of a pattern. Definitely not worth writing down. Okay, so that's the future value. Does that make sense? Does that help for everyone who wanted like a question like homework 2, question 1? Right, that's for future value. Actually, great question. Let's make this a present value. Okay, so there's 2 questions here. One is, now if I told you, first of all, let's just do, okay, no, let's do something like this. So let's say I wanted $15,000 at here. Okay, I want the value of the count. No, 15,000 is exactly, I think, the amount that I used in the homework. Let's say $100,000. I want $100,000. Let's say R is some crazy big number, 25%. Let's say S is some silly small number, like 2%. Okay, how do I solve for P? Yeah, right. 100,000 is equal to P times whatever, 1 plus 0.25 for 1 plus 0.023. Right? And solve for P. If there were 2 payments before day 3, would it be 2P? Absolutely. Yeah, that's a great question. So somebody asked if there was, let's say there's a payment on January 2nd as well. Would this be 2P? Yes, it would be. Could you, Curdy, you could, but I don't think you necessarily want to. So there's a sense in which present value is different than what this question is asking. They are very similar, but this question is asking a different thing because I'm going to withdraw on the 31st. Okay, right. So yeah, sure. Unmute and ask.
So I was wondering for what is it called? You know, the P that you just circled, you said it could be 2P if there was only like a principal value and then another one.
Yeah.
If there was like interest rates in between that, you wouldn't be able to make it 2P, right?
Right.
Oh, okay, that makes sense. Thank you.
Yeah, no problem. Yeah, the P's tend to accumulate if there are no interest rates between them. So that's actually a great way of thinking about it, right? You can just kind of smush them together. If there's a P between the 3rd and the 10th, would the P be added to the previous P? No. No, you'd have to send it forward on its own. Right? You'd have to just redo the question. Yeah. Yeah. Only if the P's, if there's a bunch of P's in here, then these P's can combine, right? And the way to see that is, again, not to, and again, I want to emphasize, don't try and meta this, okay? If there's a bunch of P's here, send them all forward in time separately. But what you're going to see is, because there's no interest rates between any of them, they all end up being the exact same value at the end of the month. And so you can combine them and get 3P. right? Right, like do you understand what I'm saying, everyone? By don't meta this, don't just be like, oh, if there's no interest rates between them, I can smush them together. Again, I can probably conceive of something to break that and a twist that could throw you off. But if you just remember, I get to send each of these things to the front of the line, and how many interest rates do they pick up? You'll realize all three of them are the exact same, and so they can be combined into 3P at the end of the month. Okay. S is the value of the account after January 31st. Yes. That's the present value. No, Davin, that's the future value, right? Could I solve this one for P? Sure. So in this case, I would factor the P out. And then I would divide that to solve for P. Okay, so now I'm getting asked about question 2. Before I go to question 2, is everyone okay about this? Like, do the things make sense here? And the present value, if I asked you for the present value of this scheme, you would get something very different, right? You wouldn't get just this divided by this. It wouldn't work out that way. Okay, so try doing the present value. And yeah, exactly, it would be less than 100,000. Jeremiah, depends what you mean there, and I don't quite understand what you're saying, so I'm hesitant to give you an answer. The 1 plus R, 1 plus S at the end. So this payment here, when we pushed it forward, it went through 1 interest rate at R and 1 interest rate at S. And remember, every time you go through a compounding event, you pick up a 1 plus the interest rate. So when I go through the blue thing, it becomes P times 1 plus R. When that whole thing goes through the S, it picks up another 1 plus S. Okay. So before going to the next part, I've also been asked, can we do this as a future or as a present value problem? Absolutely. What is the present value of this scheme? Okay, take a second to compute that. And for those of you who are worried about question 2, I'll do something similar. I can't do something too similar though, because it's almost identically, like anything I do is almost exactly what that question is. Okay, so what is the present value of this scheme? I mean, was that, Curdy, is that what you got from the other one for the $100,000 thing? I don't know. I just made up numbers. I have no idea if that's the answer. But as long as you plugged everything into a calculator correctly, it should be fine. You took $100,000, divided it by that big thing. Okay. Does anyone have the present value yet? And let me maybe copy this timeline so I can put it somewhere else. What's the copy button? That one? That one. Okay. Is it? Yes. Yes, Connie, perfect. Jacob, yes. Yeah. Yeah, continuous. Yeah. Yeah, I think so. Okay, let me take it out. Did anyone else get it? Aruba, is that from the like $100,000 one? I don't know because I did not actually plug the answer in, but you and Curdy should compare answers because you got different things. Okay, so let's do the present value. What's the present value of this first payment? Right, it's just P, right? Because you don't have to do anything. That payment is already in the present, right? Everyone's okay? Right, there's nowhere to bring it back to. We're already at the beginning. So let's take now this period or this payment. We bring it back. What do we get? Right? Yep, Jeremiah. Curdy, close. So there aren't 5, remember, right, yeah. Right, -3 and -2, right? There's 3 events at R, and there's 2 events, right, exactly. Yeah, if they were all R, Curdy, you'd be right, but yeah, those green things are at a different rate, yeah. And so there's our answer, right? So the total present value of this is that. Okay, right? Just pushing money through time, just like that. Okay, so I was asked to do a question like question 2. How do I do this? How do I do one? Let me think. No, I mean, there's no payment at the end of the month to bring back, right, Brandon? That's kind of the issue. There's no payment that pick up those interests on the 27th and the 30th, right? So they don't, like, we don't even notice those happening because there's no payment after them to see them. Yeah. Yeah, we all wish we could take money from the future. Yeah. Yeah. To get this, like for the present value problem, Curdy, like the 100, this won't give you the same answer as the 100,000 from above, right? Because they're actually different. They're different schemes. This present value is how much money would you need to deposit today to cover both of these payments, and the other one is how much you'd need to deposit in order to ensure that you had a certain amount of money at a certain point in time. I mean, so Gerpar tap, you could just like make one yourself, right? Like what would the payments be if the present value was $3,000, and then choose interest rates, right? And you know how to solve this for P. If I give you like, you know, K is equal to this, you would factor a P out. Right? And then if you wanted to solve for P, you would just divide this by the other side, right? Jeremiah, it's not that it's the present value plus the present value times interest. It's that there's 2 payments, right? So there's up here, there's payment 1. And then there's payment 2. And so what we're doing is we're computing the present value of each of those things, and then we're adding them together, right? And the reason that we add them is, you know, again, think of them as being 2 different bank accounts. And I asked you, what is the total amount of money in your bank account? You would add the 2 things together, right? So it's that we're computing the present value of all of the payments together, and we ask, what's the total value? Well, you add them all up to get the total value, right? Right. Okay. Question 2. There's not much an example of question 2 gives question 2 right away. Because the only thing I could do would basically be the same sort of question with different numbers. And it, like I said, it would give it away. So I don't think I can give you anyone a question 2 example that's similar but different enough that it doesn't just spoil it. But that being said, if you're struggling with question 2, please ask on Piazza. I think anyone here who's ever asked on Piazza before knows that we're pretty quick about it, and we'll guide people through it pretty well. What do you mean, where should we look for a guide? So, I mean, yeah, question 2 is all about effective annual rates and effective continuous rates. So you probably, look at the week 2 videos. In particular, look at the videos about effective annual rates and effective continuous rates. And importantly, you have to understand what an effective annual rate is doing. So there's a sense in which question 2 is the backwards of what we normally ask you to do, right? Normally what we do is we give you 10% compounding monthly, and we say, find the effective annual rate. Question 2 is backwards. You're given the effective annual rate, but you're not told the rate that you're compounding monthly. And you kind of have to figure that out to do the problem, right? But if you understand where those numbers come from, you can figure out what the rate is. So for this example, any payment made before the blue 3 has a present value of just P. Yes, yeah, Christian, exactly, that's correct. Yeah, because you bring it back to the present, but it doesn't go through any compounding events, right? And again, in real life, there's always compounding, right? So if you were to bring things to the present from a week, there is always a compounding event present. So we're in a kind of special world where there isn't this continuous compounding thing. If nothing else, just inflation is constantly happening. So that is a compounding rate. But yes, a very astute observation. In this example, NEPs before the blue 3 all have a present value of whatever they are. Would there be questions about bonds, amortization, perpetuity in the test? Sorry, Ariane, I'll say more tomorrow. I will tell you definitively no to bonds because there was no reading or video requirements about bonds. So bonds won't be included, but everything else is certainly fair game. But doesn't it only work with APR? Brandon, it does, but you're told that the question is APR, right? You're told that R1 and R2 are annual percentage rates. So that's why effective annual and effective continuous make sense. Yeah. So, I mean, anytime you talk about effective annual rates and effective continuous rates, they're related. The test is next week, Jacob. It's on Friday. So that's why tomorrow I'm going to post the information about what is covered. Yeah, but the test is in 8 days. Not to make anyone freak out or anything. Okay, everyone, that takes us to 7 o'clock. Is there any way I can access peer tutoring for this class? This is a great question. So for those of you who want peer tutoring, so I think first of all, make sure you're using as many of the class resources as you possibly can. So TA office hours, between tutorials and TA office hours, the TAs are available a lot, right? There's a lot of TA availability. The instructors all have office hours as well. And we also all have lecture. So, and remember everyone, you can go to as many of the tutorials, as many of the office hours as you want. You don't have to go to whatever you're registered and enrolled in. So that's a lot of resources that you can use to learn. Now, in terms of peer tutoring, for those of you who are interested in it, the MAT133 does have a Discord channel on the UTM Math Discord server. And there are lots of people who are very good at math on that server who generally love helping people with math as well. So if you want to join that, you can, and you can check that out. And that's probably your best bet for peer tutoring there. I mean, I'm looking at question 2 right now. I can literally see the words APR. So Brandon, we don't have to guess whether question 2 says APR. You can just download question 2 and see that the words APR are mentioned, right? Yeah. Will test 2 consist of readings for term test 1? Let's worry about that then. But they're generally not cumulative. Only the final exam is cumulative. Does part 1 and APR 2 of question 2 also give its own rates? Ain, I'm not certain what you're asking. Oh, wait, sorry. It does, but like part, oh, you're not asking, you're answering someone. Okay, cool. How do we go about APR when the compounding does not go through a period of 1 year? It doesn't matter. If I say you compound monthly for 6 months, you can still do that, right? You still can figure out what the term rate is from the APR. I know the effective annual rate. Edward, yes. Yeah, exactly. Okay. So hopefully I answered some of your questions. Again, everyone else, please throw on Piazza. Do not leave your questions until 9, 10 p.m. tomorrow, right? Obviously, you're less likely to get a response. But I'm going to be near my computer all day tomorrow because a bunch of my other classes also have 24-hour tests and their test is tomorrow. So if you throw questions up, I will be answering for a good chunk of the day, right? Otherwise, everyone, thanks, Jeremiah. I appreciate it. Yeah, everyone, thanks for coming. I actually have to post their test in a couple of hours here, so I need to run a little bit and get that all set up. But thanks everyone for coming. Good luck with the test. Keep an eye out tomorrow for that announcement that will give you information about the test next week, okay? All right, everyone, thanks. Have a great weekend, and I will see you next week.
Hi, excuse me, Professor.
Yeah, it just really left that to the last second.
Yeah,
What's up?
Yeah, sorry. So basically, I text you. May I answer one question for me, or?
Okay, sure, yeah.
Okay. So for
I can't hear you now though. Like you went away from your mic. Very, very barely. You know, I'm sorry, I'm not gonna, is anyone else getting anything? Can anyone else hear anything? Is it just me? Yeah. Yeah, I don't, something's going on with your mic. I don't think I can hear you, Enrin. You might just need to type it or throw it on Piazza and then I'll try and answer it later. No, I mean, like, no, I can't answer assignment 2, question 1. But like, I would say, you know, if you've, which question are we doing that was like this? Oh no, this is the January question, right? This question is very similar to assignment 2, question 1, right? So, and remember this, I've been recording this whole time. So if you missed it for whatever reason and you want to go back and watch this, I will try and post the recording tonight. And it'll give you an opportunity to go back and you'll be able to look at it. Yeah, and Jacob, yeah, I'll try and post it tonight. So Enrin, you will hopefully be able to go back and take a look at how we did this problem, but this problem is almost exactly what you need to do for assignment 2, question 1. Okay, so does that make sense? Okay, like your particular confusions, like, is it the wording at all? Like before I cut off, I just want to make sure that you understand what the question is asking you to do. So, okay, so wait, what was that yes for? So you do understand, or? Okay, so what about the question is bugging you? Yeah, there are 5 compounding events in that 15-week period. Yep. But the regularity, like where those compounding events occur, is not regular, right? They occur at different times. And that, you know, screws things up a little bit. So you have to be a little bit careful about how you deal with that. No, because it's not an APR. Right. And if you like, you're not interested in how many times something happens in a year, because you're just told this is what's happening in this one 15-week period. And that's it. You don't care about what happens for the rest of the year. Okay. So you're not trying to compute the number of compounding periods that happen in the year. It's not an APR. So you don't need to compute that. No, don't. That's what I'm saying. Don't use the formula. It's not an APR. You can't use the formula for that. You have to do it from scratch. Okay, you have to basically say you have to take every single payment individually, push it forward in time, and figure out what the value of that payment is at the end of week 15, right? Yes, I would say that the timeline is basically it's definitely not the only way to do it. Like I can do that question in my head, but I think that the timeline will be very valuable. And once you see the pattern, like once you've done a couple of them, you'll see a pattern, and then you'll be able to just zoom to the final answer. Like, you know, do a couple of them, see what the pattern is, and then I'm certain you'll pick up on it. Okay, awesome. And like I said, if you have any questions, ask on Piazza, right? Like we're pretty active there, and we're happy to answer any questions. So you can just throw it up on Piazza, we'll answer you there. No problem. Okay, see you everyone.